After the completion of derivation, the resolution of the forces into x component as well as the y component, we are going to try to solve one problem on this one. That's going to be a block. So here he has given a block is resting on a inclined plane of 15 degrees. It means that this inclination he has mentioned, not mentioned in the vertical and the horizontal. That's why I am going to be considering that is in the horizontal. If the predefined that part is that when it is making the 15 degrees without any mentioning, that I am going to be considering in the horizontal, that is the 50 degrees. A force of 20 kilonewton acts at an angle of 50 degrees with the plane. Which plane? Because this is the inclined plane. To this inclined plane, this 24 newtons is acting at 50 degrees. Determine the first one, the horizontal and the vertical components of the forces. In this case, what is the horizontal component and the vertical component? With respect to this, the block is resting. That means in the x-axis and the y-axis we need to take it. And similarly, the second one, the components of the force parallel and perpendicular to the plane. Which plane this one? This is going to be inclined plane. So that is the 15 degrees we need to take it. So if I am going to draw the diagram for this one, the first I am going to be taking in the horizontal component here. So then in this case what happened? One is the inclined plane is going to be making at an angle of 15 degrees that I am mentioning here. So that's going to be 15 degrees. And one block is going to be rested at this position. Right? Then in this case what will happen? The 15 newtons load, that is going to be 20 kilonewtons load is going to be acting with this one. So this is parallel to this inclined plane, and with this one it is going to be making, this is going to be 20 kilonewtons load is going to be acting at an angle of 50 degrees. That's is mentioned. A force 20 kilonewtons act at 50 degrees with the plane. This plane is belongs to the inclined plane. So that is going to be in this part. So in this case, this is the horizontal component and this is going to be the inclined plane at 15 degrees to the. Then how could you calculate the horizontal or vertical components of the forces? So in this case, I am going to be giving the solution here. So in this case, if you want to resolve this force into horizontal as well as the vertical, then we are going to be getting one force in this direction and one force in this direction. This I am going to say f of x and this is going to be say f of y. How we are going to be, because it is making with the inclined plane is at 50 degrees. At the same time, inclined plane is going to be making 15 degrees with the horizontal. So the totally it is going to be 65 degrees we are going to be getting. So then I am going to be considering this part is going to be, so if I am going to be taking, this is the 20 kilonewtons and this is going to be making with the complete horizontal plane is going to be the 65 degrees. So if I am going to be resolved into horizontal component and the vertical component, the first is going to be horizontal component. I am going to be say f of x is equal to, so what is this force? This is going to be the extensor as per our definition. So then the vertical component is there. So that's going to be, so this is going to be 20 kilonewtons into cos 65 degrees, right? And we will get that part. Similarly, what is the vertical component from this one? That's going to be f of y is equal to 20 into sin 65 degrees. So once we are resolving this force, then f of x is equal to, what is the we are getting? That's going to be 8.45 kilonewtons we are getting. And similarly, f of y is equal to 18.13 kilonewtons we got it. So this way we are resolving. In the second component, what will happen? The force is parallel and perpendicular to the plane. So that means this is going to be the plane axis. So this is going to be perpendicular to this one and this is going to be parallel to this one. That force we need to take it. So I am going to draw this one. This point is going to be acting 20 kilonewtons load. And similarly, it is going to be making an angle of, how much it is going to be making with the inclined plane? It is going to be making 50 degrees. Now we need to find out the two forces. One is going to be the force along this plane and one force perpendicular to this plane. So then I am going to be say F parallel. So that means F parallel is equal to, parallel to inclined plane, that is equal to 20 into, what is this component? That's going to be cos 50 degrees we will get it. And similarly, so force perpendicular to this plane, that's going to be F perpendicular, F parallel I am going to be taking here. So F perpendicular is equal to 20 into sin 50 degrees we are getting. So from this one, F parallel to that one is equal to 12.85 kilonewtons we got it. And similarly, from this F perpendicular, that is equal to, F perpendicular is equal to 15 point, that is equal to 15.32 kilonewtons we got. So these are the forces acting in the x direction and the y direction and inclined to the plane and perpendicular to the inclined plane. This way we are going to be resolving the forces.